Okay, let's make a start. It's my pleasure to introduce David Spalding. He's just joined us from the University of Strathclyde in Glasgow, and he's here to do a postdoc with Van Meeten, and he's going to be talking to us about his work looking at visual working memory and anxiety disorder, and a little bit about what he's going to be doing while he's here. So, to you, David.
Thanks, Chris, for the opportunity to kind of introduce myself and some of my PhD work this afternoon. So my name's David, and as Chris has just mentioned, I've just sort of moved here from the University of Strathclyde in Glasgow, where I was doing my PhD with Dr. Louise Nichols and Dr. Mark Bonswin. My project was mainly focused on the impacts of trait anxiety on cognition, specifically on attention and the process of visual feature binding and working memory. So for this talk, I think really the plan is just to kind of go over the 4 studies that I conducted over the course of my PhD, discuss some of the kind of implications of the findings, and speak a little bit, as Chris mentioned, about the work that I'll be doing with Van Meeten in her lab this year, and for the next couple of years after that as well. So just starting very generally with a definition of anxiety, just to kind of how we might be conceptualising it sort of throughout the course of the talk. Anxiety can be considered a multidimensional construct. It can refer to a dispositional trait characteristic, otherwise known as trait anxiety. It can refer to a sort of transient emotional state anxiety, or it can refer to a classification of mood disorder, which includes things like generalised anxiety disorder, social anxiety disorder, along these lines. And as well as the kind of trait state distinction and the classification of mood disorders, anxiety can also be characterised by different types of experience. These are typically broken down into cognitive or somatic anxiety, or anxious apprehension and anxious arousal. Cognitive anxiety refers mainly to those kind of worries that we have when we're anxious, either about current events or events that will happen in the future. And somatic anxiety refers to those kind of physiological responses, things like increased heart rate, increased muscle tension, shortness of breath. So just an indication really of the different aspects that may make up sort of the term anxiety when we're talking about it here. We'll be specifically looking at sort of trait anxiety over the course of these studies that I'm talking about today, and also the cognitive and somatic distinction. So as I kind of mentioned, I was interested in the relationship between anxiety and cognition, specifically attention and feature binding and working memory. So just as a bit of background on the relationship between anxiety and attention, the most popular sort of theory regarding this relationship in recent years has been the attentional control theory of anxiety, devised by Einstein and colleagues in 2007. Really, what is suggested within attentional control theory is that heightened trait anxiety, and particularly the worry, the cognitive component, disrupts attentional processes in such a way that goal-directed volitional control over attention is diminished, while at the same time automatic capture of stimulus-driven attention from the bottom up is increased. And this typically manifests itself in reduced efficiency in performing cognitive tasks, if you think about time to respond accurately. But there's also some evidence that it affects the effectiveness with which we perform in terms of response accuracy. Both of these do seem to be affected by anxiety. And really then the kind of takeaway with attentional control theory is this idea that anxiety might result in enhanced detection of stimuli at the perceptual level, but this comes at the expense of being able to efficiently and effectively attend to and recall information that is task relevant. And I always think this visual search evidence is quite nice for demonstrating this kind of relationship between the two attentional systems and anxiety. These 2 studies in particular looked at the effects of distractors and varying perceptual load on search accuracy and speed in a visual search task. Moser and colleagues looked at what happened when they introduced an irrelevant singleton distractor alongside the search array, and Sadeh and Redemir looked at the influence of increased perceptual load on visual searchability within participants of varying anxiety levels. And what they found in the first instance was that there was no effect of trait anxiety on the accuracy with which people searched, but there were significantly higher RTs in participants in higher anxiety groups, specifically in the presence of distractors in the visual search array. And it was also found that these response times increased in high anxiety groups as perceptual load increased. So effectively the indication there being that as perceptual load and perceptual distraction increases, so too does sort of time to respond in higher levels of anxiety. And this relationship between anxiety and attention extends to the contents of memory as well. Nick Bergen and colleagues in 2015 conducted a visual search study. They used the same sort of setup here in terms of the sort of wheel of letters where participants are asked to identify either the letter X or N, except in this case what they also did, and it might be quite difficult to see here, just beside the search array here, what they also did was they introduced a small image at the side, and following completion of the visual search task, they asked participants to recall whether or not an additional stimulus had been presented. And what they found was that there was no effective trait anxiety on the letter search task itself, but recall of these additional irrelevant stimuli increased as levels of anxiety increased, again suggesting this susceptibility to increased distraction from task-irrelevant stimuli. And switching gears slightly then, that's just a sort of bit of background on the relationship between anxiety and attention and the contents of memory, but to look sort of at the more fundamental relationship between attention and working memory out with the study of anxiety. This has been advanced quite well in recent years through the study of visual feature binding. Binding is a process by which multiple features of a stimulus, such as their shape, colour or orientation, are encoded, maintained and recalled as whole object representations. And generally it's been found this becomes more difficult when perceptual demand increases. In this figure on the left-hand side, typically speaking, these are the two different types of presentation you'll see in a binding task. Stimuli will either be presented all together or they will be presented one after the other. Typically, when stimuli are presented together, there's less demand to maintain items as they are replaced with new items, as you would find in a sequential sort of presentation style. And what's been found with this is that this additional demand of sequential presentation specifically disrupts the binding process in memory. And following on from this, sort of further advances in the binding literature have led to the development of this quite recent model of visual working memory, which takes into account these top-down and bottom-up attentional processes that I've alluded to in the study of anxiety. Really what the visual feature binding studies have done have implicated both perceptual and executive attention in this encoding and maintenance process and the recall process. With regard to this kind of bottom-up perceptual selective attention, what you would see is if you presented participants with a sequence of, say, 4 coloured shapes, the final shape would be better remembered than the ones that came before, just a kind of basic recency effect. And as well as this, with regard to more top-down executive control of attention, participants can use strategy effects to increase recall of items that otherwise wouldn't be remembered as well. So, for example, if we ask participants to view sequences of 4 colour stimuli again, but say rewarded them points for trying to recall the second item in a sequence, what the pattern might show is that recall of this second item that is typically much worse than the last item increases, but at the expense of this perceptual recency. So there's kind of an interactive process going on there between the central executive responsible for maintaining object representations and guiding attention, but also this kind of perceptual recency effect whereby items that initially enter perceptual attention are better remembered relatively automatically. And just to kind of highlight this again a bit further, looking at these specific studies conducted by Hewitt et al. In 2014 and 2016, in the figure on the left here is an indication of what happens when an additional cognitive demand is introduced in this sequential binding task. Additional cognitive demand typically decreases performance for these early sequence items that typically rely on attentional resources to maintain. And by comparison, if we introduce additional visual distraction in the form of this suffix, a to be ignored item at the end of a memory sequence, what this will do is it will interfere with memory for the last item in sequence that is typically better remembered, and therefore memory for that item will drop as well. So you can see the kind of different, almost opposite effects there of different types of distraction or demand on performance. Increased cognitive demand reduces performance for early items, and increased perceptual demand or distraction decreases memory for later items in a sequence. So to bring this all together then, in terms of what the focus of the PhD was, just to say that the effects of anxiety and visual attention that I've touched upon previously there seem to have some consequences for the contents of working memory, and this has been observed across both the neural level, sort of indications that there's less successful filtering of irrelevant information from working memory at higher levels of anxiety, and also reduced working memory capacity overall. And there is some evidence for behavioural effects of this as well. What's been found in these kind of change detection probe recognition kind of tasks where people are asked to remember colours and shapes of features or orientations of objects is that participants who are more highly anxious seem to demonstrate slower overall recall, but at the same time they may also show reduced memory accuracy. And this is just a very quick coverage of the different kind of findings we've seen so far. I will come back to a couple of these specific studies a bit further on, just to kind of provide some further context for the kind of direction that the PhD research took. So the aims of the PhD then were to determine the impact of this kind of dispositional non-clinical trait anxiety on visual working memory. Visual working memory has typically been less reliably associated with anxiety than verbal memory, and also visual memory with a spatial component, sort of memory for things like locations or orientations. But this could be because there's comparatively little research specifically looking at memory for visual features out with that spatial domain. Another aim was to kind of specifically assess the impact of anxiety on working memory through attentional processes in the context of the visual working memory model I just presented briefly there by Hitch and colleagues. So really the focus was on these kind of manipulations of executive and perceptual attention. And finally, I mentioned at the beginning there was a kind of distinction between the cognitive and somatic effects of anxiety, and really what the aim of the research was to do was to determine whether it's the cognitive dimension of anxiety specifically that affects working memory more so than the somatic dimension, as you may expect if anxious cognitions in the form of worry take up executive resources, perhaps take up verbal memory, reducing the available resources to perform a cognitive task. So these were the kind of main focuses of the project. Based on attentional control theory, as I just kind of mentioned there, you would expect cognitive anxiety to be more reliably associated with cognitive performance. It sounds kind of straightforward in that sense, but I mean, I think the evidence would suggest, or at least the theory would suggest, that this sort of increased cognitive demand of verbal worry would affect working memory and attention more so than somatic experiences of anxiety. So a quick look at the general methods that were common across all the studies here. Across the 4 studies that were conducted, each involved a variation of the sequential binding task. For each study that I'm going to cover, I'll go over each sort of specific paradigm that was used, but they were all relatively similar in the sense that we were using sequential binding. In terms of participants, we specifically looked at participants within the age range of 18 to 38 and who reported no visual or memory impairments. And we also noted and controlled for participants who were currently taking medication for either anxiety or depression in our exploratory analyses to ensure that any effects weren't masked by sort of reduced associations with anxiety or depression due to the effects of the medication. Our anxiety measure across all the studies was the trait inventory for cognitive and somatic anxiety. Using this scale, we were able to treat anxiety both as a between groups variable and a continuous independent variable in our analyses, and also separate cognitive and somatic experiences of anxiety. And when it came to our between groups analyses, what we did was we sort of set a threshold with which we would consider participants to be highly anxious. Those participants we considered highly anxious consisted of those who scored above a threshold identified by Van Dam et al. In 2013, which indicated probable presence of an anxiety disorder. And this is just a bit more of a detailed look at the STICSA measure that was used. The STICSA here effectively looks at both cognitive and somatic symptoms. As mentioned, we specifically looked at trait anxiety because we didn't manipulate state anxiety. State anxiety is typically an interaction of your trait levels of anxiety plus responses to a specific stressor. We didn't include stressors in our study, so it was more relevant to look at trait anxiety in line with the predictions of attentional control theory. And here's just an indication of the separation of cognitive and somatic experiences of anxiety in the STICSA. The items outlined here are all sort of examples of cognitive anxiety, picturing some future misfortune, having thoughts stuck in your mind, trouble remembering things, whereas the somatic experiences of anxiety kind of encapsulate these things like feeling trembly and shaky, or sort of having stiffness in your arms and legs, as I kind of alluded to earlier. With the STICSA, there's effectively 40 items measured in cognitive anxiety and 10 items measured in cognitive anxiety and 11 items measured in somatic anxiety, each scored on this Likert scale out of 4. Higher scores just indicating higher levels of anxiety. So for study 1 then, what we were interested in doing is using this visual feature paradigm specifically to assess the effects of anxiety on binding and interaction with a top-down manipulation of attention. In this case, we used a strategy instruction manipulation. So in the task, participants completed trials where they were first presented with a 2-digit number. They were asked to repeat this for the duration of the task in order to suppress subfocal articulation of the memory items that were presented. Following presentation of the number, participants were presented with 4 coloured shapes, and following presentation of these, they were presented with either a blank shape cue or a colour block cue. If the blank shape cue was presented, they were asked to indicate which colour it was originally presented in. If the colour was presented, they were asked to indicate what shape it was originally presented with. So in this example, shape cue being a triangle here, or the colour being red, this would indicate that participants were asked to recall the features of item 1 in the sequence. And what we did here was we separated participants according to relatively low, moderate or high levels of anxiety. We tested their memory for the different positions equally across serial position, either 1, 2, 3 or 4. And the strategy instruction that I mentioned has been used previously in visual feature binding studies. What we did was we, across different blocks, incentivised participants to remember different items. So say in one block we asked participants, or rather we informed participants that the first item presented in the sequence was worth the most points for recall. In another block we'd say that the 4th item in the sequence was worth more points for recall, and then in another block we'd say that all items were equal. And this is just an indication of the participants here. As I referred to before, we set a threshold for high anxiety participants. For the cognitive subscale of the STICSA, that was 24 and above, and for the somatic subscale it was 19 and above, and just an indication of the kind of spread of the participants across groups here. And in the case of study 1, it was kind of disappointing after these kind of specific theoretical predictions that we didn't find effects of either trait cognitive or somatic anxiety in performance, nor did we find an effect of our top-down attentional manipulation strategy instruction. All we really observed that was of interest was the typical serial position curve that you observe in sequential binding studies, wherein the last item in the sequence is better remembered and the items sort of placed in between the first and last item are typically remembered less well. So not too much to talk about there with respect to anxiety, unfortunately. I'll move on to study 2 quickly and sort of address the potential reasons for the lack of effects in study 1 just a wee second. But study 2 was devised at the same time as study 1 to assess sort of bottom-up interference in this binding process. So a similar type of study design again, where experimental procedure again, where participants were asked to repeat the 2-digit number out loud and remember the 4 memory items. However, in this case, prior to presentation of the memory cue, participants were presented with either a visual suffix or they were presented with a blank screen as in study 1. This visual suffix was an item that was not to be remembered. Participants were specifically told to ignore this additional stimulus when it appeared after the sequence. You'll see here that I'm referring to plausible suffixes and implausible suffixes. Plausible suffixes are those which were made up of features that could conceivably have been part of the memory array. They are from the broader pool of features from which memory items were drawn. These are typically more likely to cause interference in memory than other types of suffixes, which are these implausible suffixes, which are made up of novel features not drawn from the overall memory pool, so features that would never be asked to actually be recalled at the recall stage. Again, just an indication of the spread of the participants again here. It was quite difficult to get kind of nice even groups for this, given the kind of threshold that would set for high anxiety participants. However, in study 2, again, similar results to study 1 in the sense that there were no significant effects of trait cognitive or somatic anxiety in performance. Here we observed the serial position curve again. I referred to the end of study 1 there, but we also observed the main effect of suffix presentation, whereby both plausible and implausible suffixes reduced performance relative to the condition in which no visual suffixes were presented. So again, not much really to go on there in terms of interesting findings regarding the effect of anxiety on attention and working memory here. And really, what we did at this stage is we sort of considered, there were no effects of anxiety in these first two studies of the PhD, and we thought, like, why would this be the case? First thing to consider potentially was the response method that we used. In those first two studies, we used this kind of cued recall response method, where participants were presented with a feature and asked to verbally recall the other feature that was presented with. So really, while this was kind of consistent with the anxiety literature, the working memory and attention literature, the kind of paradigm that had been used before, it hadn't been used as often in the anxiety literature. Previous studies demonstrating effects of anxiety on working memory and attention in this kind of context have typically used a change detection paradigm, in which participants just need to indicate whether or not an item was or was not presented in the previous array. And this difference in response method may actually have implications for what kind of process is actually being tested when it comes to recall of stimuli at the end. Implicit recognition, sort of tested through change detection, is sort of less sensitive to attentional interference than this explicit recall process that we used in studies 1 and 2. And as well as this, with cued recall, participants must also remember sort of feature labels, the specific names of colour or shapes that were originally presented in order to make a correct verbal response. So this is potentially sort of more reliant on short-term memory processes, where not only do they need to remember features that were presented, but also the specific name for the feature in order to make a correct response. Change detection methods such as, these sort of implicit attentional processes such as change detection methods don't really rely on this to the same degree. So some differences there between the methodology used in the anxiety literature previously and what we attempted to use, sort of building our work on the working memory literature. Another thing to consider was the role of working memory capacity. In previous behavioural studies, effects of anxiety on working memory have typically been observed in the context of binding specifically using 3-item memory arrays rather than the 4-item arrays that we used in studies 1 and 2. But as well as this, there is some neural evidence that high anxiety is actually associated with a reduced visual working memory capacity, specifically of 3 items rather than 4. And the issue there being that in the first 2 PhD studies, we used 4 items in line with the visual feature binding literature. So it's possible that the task demands in studies 1 and 2 were sort of quite difficult for all participants who were taking part, not just those measuring more highly in anxiety, such that performance was effectively, or rather sort of differences in performance depending on anxiety were minimised, as everyone kind of found the task difficult overall. Just to provide an indication of the kind of data regarding working memory capacity here, this is a study conducted by Key and colleagues in 2014. They used a change detection response method and varied the memory load for the arrays that participants were asked to respond to. And what they found in this case was that the CDA amplitudes, the amplitudes kind of indicating the active storage of items in working memory, reached asymptote in high trait anxiety individuals at 3 memory items, whereas in the low trait anxiety group that they studied, it reached asymptote at 4 items, suggesting this difference in overall sort of memory capacity. Kind of illustrated at the bottom here, you see sort of significant increases in amplitude up to item 3 for the high trait anxiety group, and more significant increases up to item 4 in the low trait anxiety group. And in terms of behavioural evidence, I mentioned there that previously we've used 3-item arrays to test working memory here, but what we've also done previously is assess stimulus complexity. So in this paper that we published last year, we observed effects of both trait cognitive and somatic anxiety on visual working memory, but this was in the context of an interaction, and it depended on the type of stimulus that participants were asked to remember. So in this case, we used a similar feature binding paradigm and tested memory for either individual features or coloured shapes, so either 2 features or a single feature. And what we found in the case of the different types of anxiety was that trait cognitive anxiety was associated with longer binding response times, but not shape response times. So there was an interaction there between anxiety group and stimulus complexity. And interestingly, we found the same pattern with regard to correct RTs for trait somatic anxiety, but we also found reduced binding accuracy in this context. So seeing effects on both efficiency and effectiveness when it came to the effects of anxiety and working memory. And therefore, alongside working memory capacity and the response method used in the tasks. We were also wondering, is the effect of anxiety on working memory observed specifically in the context of these differences in stimulus complexity? Do they need to be observed in the context of this relative difference between individual feature memory and memory for feature conjunctions? So yeah, looking at study 3 then, we took all of these things into account over studies 3 and 4, which were planned consecutively, or simultaneously, sorry. Study 3, again, similar sequential binding paradigm, except in this case we asked participants to either remember 3 or 4 items in the memory sequence. In this case, we tested memory for both individual features, specifically shapes, or feature conjunctions, so coloured shapes. And we had a slightly bigger sample for this study. This was actually cut short due to the sort of lab closures related to COVID, but we ended up with 86 participants in each group. And looking first at the effects of trait cognitive anxiety in this study, we did observe a significant anxiety by memory type interaction, as we observed in that previous paper. In this case, moderate to high levels of trait cognitive anxiety. These participants showed better memory for individual shapes than they did for feature conjunctions, so better feature memory than binding memory. And it appeared that this effect was actually driven by improved shape memory accuracy at higher levels of trait cognitive anxiety. It wasn't a deficit whereby performance necessarily became worse. In these groups, compared to participants scoring lower in anxiety, performance didn't come worse because they were asked to remember feature conjunctions. It looks as though performance was actually a bit better when these participants were asked to remember individual features. And this was kind of significantly and linearly the case when we were looking at multi-level models here, this kind of significant association between levels of trait cognitive anxiety and memory accuracy increasing there for shapes specifically. Regarding trait somatic anxiety, we also observed an interaction. This was a three-way interaction between anxiety, the type of memory being tested, and also the set size used in the task. And what we found here was that moderate to high levels of trait somatic anxiety, these groups showed improved shape memory accuracy compared to binding as well. However, this was specifically the case for set sizes of 3 items, as we had perhaps initially predicted with trait cognitive anxiety. Interesting that we found it with somatic, but I'll come on to that in a second. In this case, though, the effect appeared to be driven by reduced binding memory as opposed to improved shape memory. This was sort of revealed with the sort of multi-level model approach again, where we treated anxiety as a continuous variable, finding a significant negative association between trait somatic anxiety and binding memory effectiveness this time. And just an indication there of the sort of differences in performance levels across all 3 groups in terms of if they were asked to remember shapes or bindings at either set size 3 or 4. Quite a steep decrease there from shape to binding at set size 3, specifically for the moderate and high trait somatic anxiety groups. So just to summarise those findings there, because it jumped a bit between cognitive and somatic outcomes. So really what we found was that moderate and high trait cognitive anxiety groups exhibited a binding deficit, but this was seemingly driven by improved shape, individual feature memory, as compared with low anxiety participants. And in the case of somatic anxiety, participants reporting moderate to high levels of somatic anxiety exhibited a binding deficit as well. However, this was seemingly driven by reduced binding memory as opposed to improved shape memory in comparison with those participants who reported lower levels of somatic anxiety. Finally then, on to study 4. As I mentioned, this was kind of designed concurrently with study 3 to kind of address some of the methodological issues we thought might have influenced results in the first 2 studies. In this case, we were again interested in the effect of set size on performance, but this time we were interested in seeing whether or not an additional cognitive load would affect memory depending on anxiety levels. So while in the previous 3 tasks that I mentioned, participants were just asked to repeat this 2-digit number at the beginning of the memory sequence, this time round there were 2 separate conditions. In one condition, they were just asked to repeat the number again, but in the other condition, they were asked to count backwards from the 2-digit number in sets of 3, thus introducing an additional cognitive load to the task. And in this case, kind of why I've been bringing it back to the participant sizes for this was just to indicate this study was particularly hit badly with the fact that it was conducted right up until we had to close the lab for sort of COVID-19 related reasons, so this was a slightly smaller sample than the previous study, although data collection was ongoing at the same time. So we're looking at slightly smaller groups here with an overall N of 68 within each sort of analyses for either trait cognitive or somatic anxiety. And in this case, findings to a point supported those of the previous study. We again found an effect of trait somatic anxiety in the same kind of direction that we would expect from study 3. Moderate to high levels of trait somatic anxiety were associated again with reduced binding accuracy compared to binding accuracy in the low trait somatic anxiety group. The difference here being though that this wasn't a linear relationship. I don't necessarily know why that's the case. I don't know if it was the sample size perhaps that played a part there. Could be slightly spurious kind of finding based on that, but again a similar pattern overall when looking at the between groups analyses. And in this case, we didn't find an effect of trait cognitive anxiety, which actually would make sense based on the results of study 3. In study 3, we found that it appears to be improved shape memory that was driving the binding deficit rather than reduced binding memory. So if the trait cognitive anxiety binding deficit in study 3 was caused by improved shape memory, we wouldn't expect to see a binding deficit in this study because there was no shape memory condition. Hope that makes sense. I think I've confused myself a bit with that, but yeah, effectively we wouldn't expect to see an effect of trait cognitive anxiety because the condition that was driving the binding deficit in the previous study was not present in this study. And with that, just to summarise then the kind of key findings from the different studies, it appears sort of that anxiety affected visual working memory specifically for recognition memory as opposed to cued recall memory. We used sequential binding and cued recall in studies 1 and 2, which was potentially difficult for all participants given the demands that were required on memory and the increased set size. Whereas we used sequential binding and a change detection response method in studies 3 and 4, which seems still to be demanding for participants measuring high-end anxiety, but perhaps not to the same extent, so potentially more room for performance to move between the different groups we were interested in. The second finding of interest was that higher trait cognitive anxiety was associated with a binding memory deficit, but in comparison to shape memory, that this was seemingly driven by an improvement in memory for these basic visual features. And in terms of some explanations for that, there's evidence from the study of social anxiety in individuals who have high social anxiety, effectively worries about sort of social evaluation, these anxious cognitions. They've been shown to show improved visual spatial working memory in a couple of previous studies, and the suggestion there is that participants measuring highly in social anxiety may monitor their environment to a greater degree. So with respect to our findings then, I suppose the question that warrants further research is, does increased cognitive anxiety, these types of worries associated with anxiety, actually result in improved memory for basic stimuli such as individual features, but not those that require further elaborated processing or more resources to maintain these colour-shaped conjunctions or bindings? And if this is the case, it would follow the assumptions set out in attentional control theory, the idea that perceptual processing, in this case for more simple stimuli that don't require further processing, is increased, but executive resources are reduced. Therefore, you would see improvements for basic stimuli such as individual features, shapes, but not these sort of colour-shaped conjunctions. And a few suggestions around the findings regarding trait somatic anxiety. We found that high trait somatic anxiety impaired binding memory to a greater degree than it did at lower levels of trait somatic anxiety. And initially this finding is a bit counterintuitive. I think I mentioned at the beginning, the prediction really with attentional control theory is that it's specifically worry or cognitive anxiety that should be a better predictor of any performance impairments associated with anxiety. So it's interesting that we're actually seeing a more reliable association with somatic anxiety, not just in these two PhD studies, but also in that previous study where we found similar results. And been thinking a bit about the reasons for this, when it came to writing up the sort of PhD thesis, and there's different explanations. I think all of them kind of require further research because it's not often that anxiety is separated according to cognitive and somatic experiences like this. So it's possible perhaps that sort of trait anxiety may be associated with closer monitoring of sort of bodily signals. This has been sort of indicated by some papers in the past, such as like Ginsberg and colleagues in 2014. So maybe the possibility that participants who report greater somatic anxiety are maybe more aware of these bodily sensations, they're interfering more with their cognitive processing because they're kind of consciously aware of what's going on, you know, this maybe increased kind of interoception, proprioception. It's also possible that self-reported somatic experiences of anxiety may actually reflect anxious cognitions, such as worry or fear. This is kind of based on some of the findings from the anxiety sensitivity literature. Anxiety sensitivity is effectively like a fear of experiencing sort of anxious experiences, sort of a fear of experiencing these kind of physical experiences associated with anxiety. And anxiety sensitivity has actually been associated with sort of more monitoring or increased perception of sort of physical experiences. The example I've drawn on here is that anxiety sensitivity is associated with reporting more severe and frequent headaches. And it's possible then that the somatic subscale of the STICSA, the scale that we use, maybe reflects a degree of anxiety sensitivity. And finally, it's also possible, you know, that participants reporting high trait somatic anxiety experience greater anxiety during the task itself. Not really get any data from our studies to say anything definitive about this. We only measured anxiety prior to the experimental task phase of each study. We didn't measure anxiety throughout. But there are ways you can do this, you know, using physiological measures such as skin conductance and heart rate, or using frequent self-reports, you know, and sort of quick responses, visual analog skills to indicate levels of anxiety as the task is ongoing. There's some sort of literature on skin conductance and heart rate stuff provided by Russ and colleagues. And I'm just going to very quickly, hopefully, try to fit it into a couple of minutes, draw upon some of the skin conductance and heart rate stuff to describe some of the research that we're going to be going on to do in TransLab over the next few years. Skip over this is just another summary of kind of what I've mentioned before. So yeah, I just want to talk very, very quickly about what we'll be doing in TransLab, looking at heart rate variability and its relationship with pathological worry and generalised anxiety disorder. Heart rate variability, if you're not familiar with it, is a physiological marker of anxiety. It just refers to the variation in the time intervals between consecutive heartbeats. And it's said to reflect the output of kind of the central autonomic network associated with emotion regulation, brain regions, you know, like frontal, prefrontal regions and the like. And there's some evidence that heart rate variability is reduced in anxiety disorders, such as generalised anxiety disorder. Some research, sort of some review papers on that recently, and some more recent findings following Chalmers and colleagues' review. And it's also been found that lower heart rate variability can predict generalised anxiety disorder symptoms up to a year after sort of measuring heart rate variability in the first place. So it's a marker of anxiety by the looks of things, heart rate variability, and what we're going to be focusing on is looking at heart rate variability biofeedback training. Training has been shown to increase heart rate variability and reduce anxiety. What happens here is that participants are actually fed back beat by beat heart rate data visually, and what they're trained to do is to synchronise their breathing rate with the heart rate that's presented to them visually in order to stimulate the cardiovascular system. This is thought to regulate cardiovascular homeostasis, and there's some evidence that it actually improves executive function after training, including in the context of anxiety and stress. However, the research is quite limited in terms of the number of studies that have been conducted and the sample sizes that have been used. So this is kind of what we're hoping to kind of advance in the next few years. So upcoming research is looking at the impact really of these these variant sessions of HRVB training on executive functions and interpretation biases in high worry and generalised anxiety disorder. It's an opportunity to kind of develop the understanding of the relationship between sort of somatic experiences of anxiety and these sort of cognitive processes associated with anxiety. The study one that we're kind of planning just now will be assessing executive functions and self-report measures and heart rate variability levels before and after this HRVB training process takes place, and comparing participants who are high in worry either in HRVB training or comparative control, hopefully to help answer some of these questions about the physiological contributions of anxiety to cognition and the maintenance of anxiety. So, sorry, I was trying to fit that in at the end there, but I think that's me now. Thank you.
Wonderful, thank you. Does anybody have any questions, either here or on Zoom?
Quick question. How correlated was somatic and cognitive anxiety? Can you separate them out in different people, or is it?
Actually, weekends they generally are pretty correlated, so I suppose there's a question there about how useful it is to separate them as measures, but yeah, I think generally speaking there's always quite large correlations between them. Can't remember exactly now, but we did sort of check those in the process of writing up and stuff like that.
Any more questions? David, please feel free to unmute yourself and ask your question.
I don't know if this is related. Can you hear me?
Yes, we can hear you.
I don't know if this is related to Fran's question. I wonder if you have, in your data you've got for your PhD, whether you've got enough people and or enough size of effect to try and break up the data, bearing in mind something like the Yerkes-Dodson theory, that anxiety doesn't have monotonic effects. It improves performance when it's low to moderate, and then its effect on performance lowers performance as it gets very strong. And you might, for example, try and categorize your participants by their scores in the questionnaire. Look for memory effects, either worsening or bettering, depending on how anxious they get, with the poor memory item, for example, and there might be other items that have specific effects within your data.
I think it's a fair point in the sample size, I think. I don't know if we do have all that many participants to try and break down the data much further in terms of seeing specific effects.
Yes.
I think that point on, I think I've got this right, it was the idea that, there's maybe some benefits at kind of moderate levels of anxiety, and then maybe less benefits as anxiety increases. Wasn't really borne out with the linear analysis that we did. I think the possibility of trying to find ways to look at that entire scale of responses non-linearly is something that I just am not familiar with the methods for that, but it would be interesting to kind of find a way around that, I suppose, and sort of, yeah.
You might see it in your effects from the whole sample. You had a middle range was less efficient, wasn't it? That doesn't fit the Yerkes-Dodson idea, which is a peak rather than a trough. But it might come out in the effects you get, rather than treating anxiety as the independent variable, as I was asking and you were taking. Anyway.
No, it's definitely something worth considering, worth having a look at the data, I think.
Yep.
That kind of thing perhaps needs to be a manipulation of anxiety within an individual, as opposed to trait anxiety. People, if you put people under varying amounts of pressure, perhaps you see those kinds of effects.
Yeah, I think generally that is where you would look at that kind of more state effect if you're sort of varying the stress levels, because that kind of state experience of anxiety is kind of that interaction between trait and the specific stressful situation. It's just, I think it was kind of beyond, sounds kind of like there wasn't a point in us doing it because there wasn't that state manipulation in a sense, and we did find that state scores were generally quite low, unfortunately, in that context. But
are there any more questions?
I guess quite a basic question in terms of the binding memory. In terms of just real life examples of how that would
differ from looking at individual events?
I struggle with that one, to be honest, because I've always studied it in that kind of very experimental context. But I think at least the idea that's always alluded to is maybe remembering, you need to remember the colour of car or something like that, you know. I struggle myself to think of a good practical application of it. I think for the sake of this research, it was quite useful just the task itself as kind of a tool almost to be able to kind of try our best to kind of tease apart effects of anxiety on kind of more complex versus simple memory. But yeah, it's one of those ones that's like I don't really have a great answer for why it would be particularly practically.
Wouldn't it apply to like identity recognition, like face, like a person's, you know, voice and face and name, just remembering people that you meet?
Yeah, quite possibly, and then that's like different types of features as well, isn't it? Beyond the kind of basics, that's like a sort of, I think, face sort of features are a whole different kind of thing compared to like shape and colour. But yeah, like things like names, that sort of cross-modal stuff as well. Yeah, I think that's probably a better example, definitely. Yeah.
Would be sort of, if you were to look at a picture or watch a video or something, like looking at specific details of it rather than the holistic situation, would that be quite comparable to that?
I think so, yeah. It gets kind of, again, interesting from the point of view that if you're looking at something that's considered a discrete object, like if it was a painting, like what, that's something discrete in that compared to looking at the whole painting. It's interesting that, I think, like to the kind of extent to which you're integrating all that different information within a painting, maybe. But yeah, I think it is comparable in the sense that if it was like an individual person within a picture, maybe.
Okay, I think we should wrap up there. Thank you again, David.
Thanks.
Thank you, everyone at home. Next week we're going to have project proposal presentations. So see you next week.